Who's excited about AI in building design? Good. Who's nervous? Almost the exact amount of people. Okay, good. So I'm here to get you excited about this and try to quell some of that nervousness. My name is Kevin Lawson. I'm a professional engineer. I've got about 12 years of experience designing HVAC systems, so I was a consulting engineer for a long time. About 2.5 years ago, I left and I founded Ripple, and we use AI to automate HVAC design. So in practice, what that means is we have a Revit plugin that automates HVAC design. So we've got 2 Revit plugins, one for HVAC engineers and one for architects. Our tool for HVAC engineers has about 1,500 users. We're onboarding about 100 firms every month. Our tool for architects has just come out, but we're expecting similar growth. The reason these tools are free, the reason I'm telling you this is just to say this is about today. I'm not talking about at some point in the future how AI is going to eventually come in. This is things you can be using today. So I normally talk to HVAC engineers. So I've tried to broaden the conversation a little bit because I know we have a lot of people that probably aren't HVAC engineers. So just to get a kind of an idea of who we have in the audience, how many HVAC engineers do we have in the audience? Okay, a couple. How many architects? Okay. How about builders, contractors, anybody? Okay, great. So a couple HVAC engineers, lots of architects, lots of builders. That's awesome. I think as questions come up, feel free to raise your hand, shout them out, whatever you want to do. This is a complex topic, broad topic, new topic. There's no experts in this field. I'm certainly not an expert. I'm just wanting to come here and talk to you. So if you have anything to say, I'd love to hear all your thoughts and all your questions. So just shout them out when you feel you need to. Okay, let's go over the agenda. Okay, first we're going to talk about what is AI. Who knows what AI is? Okay. And we're going to talk about what is a building. Who knows what a building is? Nobody? You guys don't know what a building is? Is that the first RFI? Okay. But really, I want to get on the same page as all these definitions, so we're all kind of like talking the same direction and not talking past each other. Okay. Then we're going to talk about what do we want out of AI and building design and why. We're going to talk about how technology has ruined building design. We're going to talk about the role of BIM. We're going to talk about how AI will save building design. Then we're going to talk about the impact of AI in building design on architects, engineers, and contractors. So, there's where we're going. Okay, so first question, what is AI? So AI takes an input, you feed it through AI, you get an output. If that output is human-like, it's AI. So ChatGPT takes a text question, feed it into ChatGPT, and it gives you a text answer. ChatGPT 1 did not give you a coherent answer, so no one called that AI. No one heard about ChatGPT 1. It wasn't until ChatGPT 3 that it started giving you a human-like response, and now all of a sudden that's AI. Now there are many examples of this. So like DALL-E is a text input to an image output. So like if you ask a person to draw me a picture of 2 minutes ago, they would draw you a picture of 2 minutes ago. DALL-E does the same thing. Human-like response, we call it AI. There are many ways to get to that output. Everything from symbolic artificial intelligence expert systems. This could be something as simple as a flowchart. So one of the first AI systems was called Mycin. It was a computer program. You told it symptoms like you would a doctor, and it put out what the infection was. So it's for blood infections. Symptom this, and it would ask you another set of questions. Why? This is the blood infection. It gave you a response as if a doctor would give you a response. There's machine learning or supervised machine learning. This is what ChatGPT is. It gives you a text answer. Tesla's full self-driving is AI. You get in the car, you tell the car where to go, it drives you there like a person would drive. cruise control is AI. You tell the car the speed you want to go, it goes, it modulates the speed of the car just like a person does. Just like a person would. So, you may think that's kind of a cop-out, we're just calling everything AI, but I drive behind people all the time on the highway that can't maintain steady speed. Do those people lack intelligence? Of course they do. Of course they do. That's why cruise control is AI, because it is intelligence. Okay, what is a building? This should be an easy one, but it's going to be the same thing. Because a building is a system of systems that supports architecture. Okay, so for example, it's a combination of a wall system, a roof system, an HVAC system, a structural system, etc. It's probably named hundreds of different systems. But this kind of begs the question, what's a system? A system is a combination of components that work together. So an HVAC system is an air handling unit, terminal units, diffusers, ducts, things like that. It also begs the question, what is architecture? And this, as an HVAC engineer, is kind of hard for me to answer, but this is the best I can come up with. It's space made to provide a form and a function. So a house has a certain shape, provides a function, people will live in it. A school, certain shape, function, people learn in it. Hospital, certain shape, people heal in it, have surgery. So note that this presentation is AI and building design. So for most of this conversation, we're going to assume we have the form and the function of the building. Architects out there, how did I do? Is that reasonable? All right. Okay, so while we're talking about architecture, and we're kind of cheating, like you're saying, we're going to pass over AI and architecture. Is that something that we could apply some systems? Could we take some owner's project requirements and building site and feed it into some AI and output architecture? Is that something we could do? I don't think so. So first of all, it wouldn't really be AI. It would be, there's some creative aspect to making the form of the building. The other thing is there are so many loose and fuzzy interactions with architecture, with people, that it makes it very hard to create a system that can output architecture. So HVAC is very easy. We want the inside temperature to be this, the outdoor climate is this, the walls have thermal properties. It's very hard numbers. Architecture is very loose. So if you think about things like that should be hard rules, they're not really, like zoning. Zoning should be a perfect example. It's a list of what you can build where, what the setbacks have to be, nice list of rules, right? Not really. It's mutable. So like a person would know, hey, we can get a variance on this rule, and now all of a sudden the project totally changes. So how is an AI going to know? Hire this lawyer, talk to this alderman. It's just not. It's not something that really works out. So we can't do that. So what do we want? We want to feed architecture into AI and get the building. So a building is just a system of systems. So you're probably going to have a separate AI for every system. So and when you sum all the systems up, you get a building that supports that architecture. At Ripple, we started with the HVAC system, and we'll get into why later, but I'd anticipate there will be AI systems for all of the building systems, electrical, plumbing, structural. So, okay, why do we want this? Why do we want AI in building design? Building design is full of dependencies. So a dependency is something that one person needs but can't provide themselves. So an architect needs to know the size of the mechanical room to decide the building. The architect can't determine how big this mechanical room needs to be themselves, so they have to hire an HVAC engineer. Not only do they have to hire the HVAC engineer, they have to communicate with the HVAC engineer. They have to send them the entire form and function of the building, all of that information. The HVAC engineer then needs to do all the calculations, design the system, and communicate back with the architect. The mechanical room needs to be this big, and that communication is slow and error-prone. So engineers don't understand architectural plans all the time. So, and it's very slow. You have to wait. You know, it's missed phone calls, missed emails that go spam. It slows the design process down to a halt. Introduces all kinds of places to make mistakes, and that ends up with poor designs. So I'm actually advocating less communication to building design. This is probably not something that you'll hear anywhere else in construction. Most people talk more communication, more communication. I'm saying less. And I didn't come up with this myself. When Amazon was building AWS, they had a similar problem. Very complex business, lots of interdependencies. They were just ground to halt in meetings and emails. And so Jeff Bezos famously said this: if we want Amazon to be a place where builders can build, we need to eliminate communication, not encourage it. And that's what they did. And we'll go over what their solution was and what the corollary is going to be in the building design space. But that's the gist of where I think we're going in building design, is less communication. Now, okay. So let's talk about some of these dependencies. So this is a few of the building design dependencies. Definitely not all of them, but this is what we put on the slide. And this slide is meant to look confusing, because it is confusing. It's a complex, designing a building is a complex system. So let's just follow like one of these paths. So the architect provides, along with the form and function of the building, they provide, let's say, the thermal properties to the HVAC engineer. The HVAC engineer designs their system, outputs shaft and mechanical designs. That goes back to the architect, and that goes back to the structural engineer. The structural engineer designs their system, and they have beams and column sizes that the HVAC engineer cares about, because their duct has to be underneath those beams. Now, the point of this slide is to say that it's complicated and that it's a web. It's not a linear thing that can happen. Every engineer depends on outputs from other engineers and the architect. So they all have to meld together, and that means that building design has to happen at the same time. You can't just design the architect, hand it off to the HVAC engineer, and hand it off to the structural engineer, because all their designs impact each other. So you have to do it in parallel. And that introduces some bad incentives. So if I'm an engineer, time is money. I make money billing hours, and the quicker I get done with this, I can take more profit. So I only want to design a system once. I only want to touch a system one time. So if I'm the HVAC engineer, I want to wait as long as I can, because if I design my system before beams and columns are in the model, now I have to go back, redesign my ductwork, pull my ductwork down, make it a different shape. It's a lot more work for me, as opposed to if I just waited for the structural engineer to do that. Now, this always ends up in design as either compromises or just bad design. So if I'm an HVAC engineer, I wait till the last minute to design my ductwork, I put my ductwork under my beams, then I go to the architect and I say, hey, those 9-foot ceilings you wanted, they need to be 8. So if I wait till the last minute, it's more likely that the architect is going to say, fine. If I put that 6 months in advance, the architect might say, well, let's raise deck to deck. Now I have to rerun loads. It's more work for me. So it's better if I just wait. Honestly, it's better for me if it just gets discovered in the field and you have to drop it in the field, because then that's no work. I hope I'm making some of your blood boil. But that's what happens all the time. And it's because you're incentivized to do it, because you don't want to touch the design more than once. So I call this the AE game of chicken. So chicken is a game where two cars speed at each other. The first one to turn off loses. Building design is a game of chicken where everyone's racing towards the deadline, which is mutual disaster, and the engineer that starts work first loses. They're going to be less profitable than the other engineers. And that's not every engineer. Of course, there are engineers that don't play this game of chicken well, but they're hard to find. They retire. Things happen. So is this kind of ringing a bell to anybody? Is this when you call your engineer and they don't answer? Are they avoiding you, or are they really that busy? I can tell you from experience, I'm avoiding you. So, because I want to wait till the last minute, because I only want to have to touch my system once. Now, so my builders out there, my contractors, drawing packages, bid packages are getting better over time. That the drawings that you get today are better than the drawings you got 10 years ago. Who thinks they're worse? Okay. Now, I think there are many different reasons for that, but I think the main reason is that technology has made this game of chicken worse. It's made it harder and harder and harder to play this game of chicken. So how do we use to communicate with each other? How did the architect use to convey the form and function of a building to an engineer? Mylar prints, right? They physically drew something, rolled it up in a tube, and couriered it to the engineer. Now, when I got those Mylar prints as an engineer, I was pretty certain that is the building you wanted an HVAC system for. Because if it wasn't, you would have to re-hand draw this, re-roll them up, resend them to me. It was a lot of work for you. So these prints acted like a goalpost, like a very good goalpost. It was not going to get moved. I knew the target. It's what I needed the system designed for. Then what happened? How do we communicate after my life? Free Tuesday to anyone who can answer. CAD. Now I can just email a background to you. So now it was almost no work to email you a change or an update. So this is an email from Frantic Architects. This is the final update for the printing tomorrow. Ignore the last background I sent that was said it was the final update. Sincerely, Frantic Architects. So this made the goalpost very easy to move. But it's still a goalpost. It's still the HVAC engineer can still say, I'm not updating backgrounds. I'm not, we can do an addendum if necessary, but I'm not doing anything more. Now what do we have? BIM Collaborate Pro. Now we have your live model linked into my HVAC drawing that changes, and I don't even know about it. There is no goalpost. We totally removed the goalpost. I don't know when you want me to start. I don't know what building you want an HVAC design for, and it's just making this game of chicken harder and harder to play. So I think that's where technology has hurt us. But technology has helped us in a lot of other ways. And it's really, it's been hard, but it's also been good. So what BIM has given us is it's given us data. It's given us data to add context to our design. So with our Mylar prints and with our AutoCAD, these are extremely dumb drawings. The computer knows nothing about these except for there is a line here. It doesn't know that this is insulation. It doesn't know that this is brick. It just knows that there are lines here. So if you were to try to apply AI to hand drawings or CAD, you would need a whole separate system just to interpret these lines model as a window element. I could just take that information and pull it out and run it through the AI engine. So it's a step change in terms of AI and automation. And of course, AutoCAD is losing popularity over time, and is gaining popularity over time. The other thing that this does is that it helps us communicate, basically. So the problem here is communication. So we can communicate better. You communicate that that's a window, not just in terms of a drawing that can be misunderstood, but something that is solid. So remember Jeff Bezos, Amazon, AWS, they're building lots of complex dependencies. What did Amazon do? So Amazon, to create no more meetings, no more emails. If you owe somebody information, you put that information available through a web interface, and you write instructions on how to access it. So if somebody needed the information from you, they went to you, or they went to your web interface, read your instructions, got the information. If they couldn't do that, there was a problem, and you fixed your interface. You didn't email, you didn't have meetings, you fixed the interface so that other people can access your data. This allowed other people to access your data asynchronously. So you weren't bothered when they were trying to get your data. You didn't have to stop and have a meeting, you didn't have to stop and answer an email, they just got your data. So by maintaining those interfaces, they were able to get rid of all of the communication overhead and go on and they built AWS, which is one of the biggest and best businesses out there. So I think the corollary for building design, instead of communicating through service interfaces, is we're going to communicate through the model. So if you're an architect, you need to tell the HVAC engineer how many windows there are, how big are these windows. You do that, don't email them that information, put it in the model. But you guys already put that stuff in the model, right? You already put the window size in the model. That's how you communicate to the contractor. So most of the work is already done. Most of the information the engineers need are already in the model. There's just a couple pieces, like thermal properties, don't get in the model very often. But if we can make a system where you put the right information in the model, now you can start feed that. Now you can feed that into an AI, and you can instantaneously do that. And this is how the Ripple plugins work. We take your architectural data, we run it through a building system AI using the Revit API, and we design that building system. So we take all the information we need out of your model, we design the building system. But this is still one-way communication. So what Ripple also does is we take that dependency data and we feed it back into the architectural model for the architect to have that info. How big is the mechanical room? How big are the shafts? How heavy are they? How much does it cost? What are the electrical loads? So this is kind of a generic flow diagram for how communicating through the model works. Now this could be an HVAC system, a structural system, any type of system, but most systems are just based off, go back to that dependency chart. It all stems from the architect. So this is the way automated HVAC design works. We take that architectural model, we pull out the building geometry, the thermal properties, the glazing ratios, the project location, space usage. We run it through our product called Engineering on Demand. We design an HVAC model, so we create a totally separate model that's HVAC. And then we take the dependencies out of that model and drop them back into the architectural model. So mechanical room sizes, shaft sizes, electrical loads, equipment weights. And we just drop that back to the architectural model so the architect knows now, hey, I need a 10 by 20 mechanical room. It works best for my building over here. And they can do that in the middle of the night. They don't have to call an engineer. They don't have to send an email. They get that instantaneous feedback. Now, as the project changes, now I actually have more data. So now I have data that where the mechanical room should go. So if you, say, take out a classroom, move the classroom down to the end of the hall, put the mechanical room in, and rerun it, now I have more information. I have information So this is kind of, 50,000 lines of code wrapped up into one spreadsheet. So there's a lot of detail that you can go into or not go into, but this is the general consensus of where I see AI in building design is give the architects instantaneous feedback, remove dependencies. So in this system, you're removing the HVAC engineer as a dependency. Now that's great for architects, that's great for building design, that's great for construction. It's bad for the HVAC engineer, right? I don't think so. So the impact on HVAC engineers, first of all, algorithms can't sign and seal plans. So you are going to have an HVAC engineer involved to review the output, review the output, sign and seal it, make corrections to the algorithm. It's like training ChatGPT. You need that feedback. So you can't really completely eliminate the HVAC engineer, nor would you want to. But you will improve their productivity maybe 10 to 100 times. But so that you still would consider that bad. But there is so much work for HVAC engineers to do. First of all, we need more buildings. I mean, most engineers are slammed right now. If they got done 10 times faster, they would just move on to the next project faster. We need better building designs. So there's a lot of things that we don't do in design that we could be doing. Better coordination. Now, all that stuff is easier the more automated things get, but those designs could be better. We could be spending more time per design. Many buildings aren't cost-effective to automate. It makes sense to automate schools, offices, the common buildings that we build with a lot. It doesn't make sense to automate a manufacturing facility that you're only going to build two of, in the next 20 years. So you still need HVAC engineers for that. Many buildings don't get engineered at all currently. That could be residential. There's typically not an engineer involved. That would be great if they were involved, but there's not available. All those buildings need to be built. Those HVAC engineers will be managing the construction of these projects. And then you've got existing buildings. So existing buildings come in, there's really two flavors. One is to have an automated design, you need a very good model, which existing buildings, sometimes when you're doing renovations, you don't make a very good model of that. And then you've got to tie into the existing systems, and all of that is just so hard to automate. And there's a lot of work. The other thing is energy. There are a lot of buildings just burning energy pointlessly because there's not an engineer to go and look at them and make them right. So that's just like an ocean of oil. Does that help the HVAC engineers in the crowd? Okay, impact on architects. I think that the impact on architects of this is going to be the biggest. And the way I think about it is, does everybody enjoy taking a driving a car, just kind of zoning out and driving? Do you think you would enjoy that if you had one engineer on the brake, one engineer on the steering wheel, and one engineer on the brake light? That would be maddening, You're like, okay, all right, hit the brake, hit the brake, hit the brake. And then you get rear-ended, and the engineer on the brake light is like, well, you didn't tell me to turn the light on. That's a frustrating experience, right? That's frustrating for you to do. Now, by extending the architect's capabilities and removing these dependencies, it will be so much easier to design a building. And so here's an image of an architect. This with Dowley made this as an AI image. There's an architect managing engineers driving a car. There's an architect. Notice he lost his right. Okay. Impact on contractors. We've seen this on a set of plans. Plans are diagrammatic in nature. Contractors should coordinate in the field. Who likes seeing this on plans? Does that give you confidence that you're not going to have any problems, or does that increase your stress level? So I will say that I think in the past, these things things kind of did make sense to do. It used to be very hard to coordinate on Mylar or on CAD. It was hard to coordinate in the office. And it was much easier to coordinate in the field. You could just see, oh, hey, we can put hangers here, we can do that. The other thing is, it used to be that the office labor was expensive and the field labor was cheap. Now that's turned around. So our capabilities in the office with BIM and AI have gone up, and the cost has built on the side. So I would like to start seeing less of this. The contractor shall provide coordinated trap time before commencement of work. That should be done